Alright, so here is a quick explanation of all the big points, or like the most important parts of the code for the basic tic-tac-toe. So remember that there's like sort of two parts of the project. There's the tic-tac-toe, which is sort of like a starter task. So it just implements tic-tac-toe. The only difference is that you can specify the size of the board, so it can be like 10 by 10, and then you also specify the number of pieces in a row you want in order to win. So you can make like a 10 by 10 board, but you only need 6 pieces in a row in order to win the game. Something like that. So that's the only variation for this one. There is another branch called Ultimate Tic-Tac-Toe, which is a different game mode that has a little bit of extra rules, but that one implements that. But I'll first be talking about Tic-Tac-Toe, which is this one. So if I look at the project files on the left side, let's go through all the folders. So lib, this is just like some jar files. These jar files allow you to run JUnit, but they're inside of every repo, and then IntelliJ will automatically detect and like load them on each time. But you don't really need to know this unless you're really trying to restructure the entire project. And then all of the Java files are inside of this source folder. There's only one package, which is tic-tac-toe, and then there's these 4 files. So all of the most important code, and pretty much all of the code, goes inside of tic-tac-toe board. This has all the game logic, checking how you win. It's also how you make moves, and it has a lot of helper functions. It makes use of a class called pause. It stands for position. It's basically an XY pair, so it holds an X and a Y, and has a couple of helper functions for like quick like XY additions. It just makes life a little bit easier in terms of dealing with XY coordinates, because tic-tac-toe is on a 2x2 grid, and you need to deal with a lot of like coordinates. As a result, there's like a multiplication function, there's an addition function for like different types of position objects. There's a string for printing it out, and then there's like a hash code. But it's pretty straightforward in terms of this one. It's mainly just a utility function. I'll get to tic-tac-toe board last because that has the bulk of everything. Tic-tac-toe board tests. So this is the JUnit test file. So it has all of these. Let me do this. Okay, so it has all of these different tests, which are unit tests, and they test very individual parts. This make move test is technically an integration test because the make move basically utilizes all of these functions. And then one thing to note is that for these bugs, because I think the bug usually is with like the test that will fail is usually this make move test, and it's kind of an integration test because it relies on everything else. One thing you should tell the students is that these tests aren't comprehensive, as in make move might fail, but that might be because of an issue with the check win function or an issue with the set get function, and the tests aren't comprehensive. So don't, just because it passes the check win test doesn't mean that check win is 100% correct. That's pretty important. So then, but these tests, if you look at them, it's a lot of just making moves and then just using an assert statement to check one thing. So once you sort of look at how tic-tac-toe board works, most of these tests should make pretty intuitive sense. I added some comments, but I'm not super sure how useful they are. Okay, and then there's tic-tac-toe game. So tic-tac-toe game is just in case you actually want to play the implementation. Less interesting on the tic-tac-toe version of the code, but on Ultimate Tic-Tac-Toe it's a little bit more interesting because you can do a lot of things. It's a pretty new game mode, and people can try that one out. But yeah, if you want to actually play the game, all of the game and like turn logic is implemented here. There's a couple of like helper functions, but if you just run this main method, which let me expand that. If you run this main method, these are the settings for the board. So this says I want a 3x3 board, and then I want to make sure that you have 3 pieces in a row in order to win. And that's just the standard game of tic-tac-toe. Cool. So the very last thing is, there aren't any bugs in this one. This is mainly just if students want to test out the code, or something, like they want to play with it in their own hands, then they can use this. But all of the actual game logic is inside of this class, the tic-tac-toe board. So let's quickly go over basically all the components of it. A lot of this, and I'll be honest, the majority of this is just a lot of helper functions. A lot of like helper functions and like setter, getter functions. The only like real interesting function is this check win function that checks whether or not whether or not the last move you made caused a win. Like is it a winning move? But everything else I'll sort of just explain quickly. So the way that we represent the board itself is a 2D array of integers, and then each player is an integer. So x's are going to be 1s, and then o's are going to be 2s, and then if the space is empty, it'll be a 0. So yeah, basically everything is just these integers, and it's just probably the easiest way to deal with the players. One thing to note is that anywhere in the code, if I want to specify like, oh, I'm putting down an X player or a 0 player, I always want to use these variables. That way you just don't get the 1s and 2s mixed up. Just a little bit of a style thing. In DIRs, so this is a variable that's used only in the check win function. So I'll talk a little bit more about DIRs later when I talk about check win. So width and height, these variables just specify the size of the board, how big is the board. This is the only variable that probably isn't named very well. It's just the variable n. The variable n means how many symbols do you need in a row, diagonal, or column in order to win. So in a standard game of tic-tac-toe, n equals 3, because you need to like have 3 x's on the diagonal in order to win. There's a variable that keeps track of the number of pieces, like currently on the board. There's a boolean that says whether or not someone has won the game. You keep track of who won the game. And then winning endpoints, this is just a display feature. If you ever want to like make a actual GUI for the project, you can like draw a streak over like, are you winning over the diagonal or the column or the row? This tells you like where that line should be drawn in terms of like after you won the game, where do I draw the line to tell who won, which is just like a small feature. I never actually have that GUI which displays this line, but it just keeps track of like on the continuous row of winning symbols, where are the endpoints. Okay, so here is just a getter function, checks whether or not you've won. This is a getter function for the endpoints. Getter. This is just a simple function to see whether or not the board is completely filled. I'm not going to go over all of these functions just because a lot of them are straightforward. So here's some more getter functions. One thing to note is that these get functions, these always refer to the board itself. So if I do get 0, 0, that's basically getting the player that's currently in the 0, 0 coordinate. So it can either be x, 0, or nothing. You'll basically just be returning that int, which is either 0, 1, or 2. Set does the same thing. And then one thing to note is I have a set function which will like put in an x on the board somewhere. And then you also have a make move function which will also put in an x on the board. Basically they do the same thing, except make move implements game logic. So set will just change the board. So it'll physically, like the entire function is just this board, and you set the position to the player. If I look at this make move function, make move does a lot of extra game logic. So I check if the move is actually valid. I check if the player is valid. I check it, then I set the board, and then I also check if the player, or if that move caused a win. And then I update the number of pieces, and then I also return whether or not that move created a win. So there's like a pretty big difference between set and make move. In terms of set is just using for manipulating the board, but make move is usually the function you want to use because it keeps all of the variables in check, because it updates everything, like num pieces, win, and then checks the players too. Cool. And then, okay, so down here, there's 3 functions. Note that I just skipped over check win because that one's really long. The 3 functions down here are all GUI functions. So these are all for when you run the interactive game. This is how you display the entire tic-tac-toe board. It's basically like a lot of string additions and a lot of like iterations and like combining strings and printing out strings. That's all it does. So nothing too complicated for these. There's no bugs in the GUI functions, so you can tell the students that, and they basically just have to know that they're there, and they can use them while debugging in order to help them see the board state, because sometimes they'll be pretty complicated, especially in Ultimate Tic-Tac-Toe. So they can definitely use these functions in their tests to help them debug. Cool. Okay, so last thing to explain is this check win function. So let me open these. Okay, so the check win function is pretty big, and this is mainly, honestly, most of the bugs in this project are mainly inside this check win function. So when I explained the code to the students, I basically told them like very little about the rest of the code, and I spent most of my time explaining this check win function. So let's see. So the way that check win is used is after you place a move. So usually inside the game logic, I repeatedly call this make move function. And remember that make move, at the end of making the move, it'll check whether or not I've created a win. So using this check win function. So if player X is about to win, and like say the top right, putting an O in the top right causes a win, after I put that top right O, this check win function gets the position of that top right O, and then it says, oh, okay, does this result in a win? And the way that I check whether or not that move creates a win is from that X, I will check in all directions. So actually, let me pull up a visual. Okay, so here's a quick visual of that check win function. So the check win function, it says it's called after a player makes a move at position XY. So let's say X goes in the very middle square. So then the check win function will be passed in the position of where that move was made. So in this case, it's that very middle square. And from here, you basically want to check all possible winning directions, as in which directions is it possible to have, let's say, 5 in a row. So right now, I'll check this horizontal line. I'll basically check all the squares to the right and left of it and see if there's a continual streak of X's. So look like X, 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 X. I don't know if that's the case, but the code will start checking in those directions to see if X's are in those directions. And then if not, then I'll start checking the diagonals. So I'll say, oh, is there an X here, X here, X here? And then if not, I'll keep going. And then I'll check the column, the other diagonal, and then like all rows, yeah. So everywhere extending from this X. So there's basically going to be, for each direction, there's going to be 2 iteration steps. One in the positive direction and one in the negative direction. So that allows all X's in both directions, counting from the current position. So that's sort of the iteration step. So yeah, so everything is listed inside of this stirs variable that tells you, oh, what are the possible directions that I should be looking in terms of how I'd want to iterate. And if you actually look at this, there should be 4 distinct directions. So there can be this row, this column, and then this top left to bottom right diagonal, and then the top right to bottom left diagonal. So there's those 4 directions. Okay, so that's basically what the check win function is doing. Now I'll sort of relate that to the actual parts of the code. So this introduction part is just like you basically get the player that just made the move, because right now you only pass in the position of the move that you're checking whether or not it caused the win, but you don't know which player it is, right? And then this is just a quick uh, sanity check for the actual code. It doesn't do too much, but this is the main bulk of it. So you see that we actually iterate over all of the directions. So that's the 4 directions I talked about earlier. And then for each of those directions, I have this bulk of code, which is first, this is the first iteration where I check all of the symbols in the positive direction. I count those, and then I start moving in the opposite direction, so the negative direction. So first, if I'm looking at the X in the center of the board, this one looks at all of the pieces to the very right of that, and this is all the pieces to the left of that. And after that, I add them together, and I see whether or not that is enough to constitute a win, right? And then if it is a win, then I return. And if it's not a win, I keep checking the directions. So let's actually look at the directions. Each direction is represented as this position variable, but it's kind of it's kind of a bad naming to call it a position. They're actually kind of like vectors. So basically what happens is we take our current position and we keep adding this vector. So if we're currently at, let's say, 3, 3, and we keep adding this first position, only the X changes. So it goes like 3, 3, 4, 3, 5, 3, 6, 3. So you see that we're only moving along the row. And then if we look at this one, we add 1 and 1. So it'd be 3, 3, 4, 4, 5, 5. So if you actually look on the board, that's moving a diagonal. So each of these represents one of those 4 directions I talked about earlier. So let's go back to the DIRs, or the actual code. So then what happens is our current position, that's our starting place. If we count that symbol that's already there, we have already 1. So if we're counting x's, that means we already have 1 x in a row. So now the pointer starts moving in that direction. So I take the current position, I add it to the direction, I update it by like one of those direction units, and then that pointer moves in a certain direction. So it'll like move to the right if the vector is 1, 0. So it'll keep moving to the right. And then every time I move to a new position, I check, okay, is it a valid position on the board? As in, have I gone off the board? Is it greater than the width or height of the board? And if it's not, I also make sure that the current symbol at that location is my original player. So if I'm counting x's, if I hit an O, I basically want to stop counting. But if it's another x, I keep counting. So that's this basic while loop. And then every time I add 1 to my count, and then I update the pointer, and I keep moving in that direction. So that's basically both of these for loops. The only difference is that this one I go in a negative direction rather than that positive direction. So I have these 2 iterations that count up the number of x's in a row or the o's in a row, depending on who made the move. And then over here, I see if my count is actually greater than the n, which is the number of pieces in a row you need in order to have a win. So if you do win, then you just update all of the winning variables. So like these are the stuff that tracks who won and how did they win. And then you return whether or not anyone won. So that's the bulk of the check win function. Hopefully that made sense. If not, there is a design document and some hopefully useful comments that will let you like clue in on how all of this stuff works. But yeah, I guess you can leave comments leave some comments to ask more questions in this video.